Good afternoon, everyone. Welcome back to NLP course. And today we will continue our lecture to chapter 6, which is about introduction to text classification. And here is the outline in these lectures. We will see on what is the text classification study about and what we can do with text classification, following the guideline and evaluation methods. And last but not least, we will take a look on supervised and unsupervised learning. What are the main difference between two of them? So now we move on to the first part in this lecture, which is introduction to text classification. Before we move on to the lecture, we will need to understand some terms which are used in text classification as well as in machine learning. So the first one is we call model. So what is model? It can be a mathematical representation of a real-world process. So in your model, you want your model to do something, so you represent those method, those procedure into a mathematical way. And to generate a machine learning model, you will need to provide training data to machine learning algorithms. So in here, to build a model, we need a training data as well as a learning algorithm. So what is learning algorithm? It is a hypothesis set that is taken at the beginning before the training starts with real-world data. So what does that means? We need the machine learning. Before that, we can start what we want to do with that. So there are many possible machine learning algorithms that we can select based on our requirement. So next we come to the third term, which is training. While training for machine learning, you pass an algorithm with training data. The learning algorithm will find patterns in the training data such that the input parameters correspond to the target. The output of the training process is a machine learning model, which you can then use to make predictions. So in the training process, you allow your training data to be built for a model so that you can use it for the next prediction whenever you have a new data. So when we say target, it is whatever the output of the input variables are. It is actually, for example, in the text classification, you want your inputs text, you need to classify it whether it is an sport or articles of politics or technology. It is the way you define the target of this input. And next we come to regressions. Regression techniques are used when the output is real value based on continuous variables. So this is not they're totally different from classification problem because this one is involved with continuous variable. And another important key term is called overfitting. An important consideration in machine learning is how well the approximation of the target function that has been trained using the training data, and it can generalize to new data. So we say that a model is overfitting if it fits the training data too well, and there is a poor generalization of new data. So that means you have your training data and your model can give you a very accurate result. However, it cannot give you any new data from your training. And next, we have regularization. It is the method to estimate a preferred complexity of the machine learning model so that the model generalizes and the overfit or underfit problem is avoided. So with this regularization, we try to avoid the overfit as well as the underfit problem. So this is done by adding a penalty on the different parameters of the model, thereby reducing the freedom of the model. So in the model, it uses different type of learning algorithms. So it has some parameter, or we call it parameter tuning. So what is parameter? Parameter and hyperparameter, they are configuration variables that can be thought to be internal to the model, as they can be estimated from the training data. Algorithm has mechanisms to optimize parameters. So If once you have selected a specific algorithms, there is a way that we can try to adjust, try to vary different parameters, allow for this particular algorithm. So next we will see on what is text classification. It is a way to categorize documents or piece of text. So you try to categorize some information by examining what you say in a piece of text. Classifier can decide what class label to assign to it. So when you say class label here, it actually the topic of the text or the target that you want it to, for example, in your scope of work, you are trying to check whether this tag is belong to technology, sport, fashion, politics, or some other topics. For example, in a box, it represents the text document. It is represented as a raw data, so you have many text, and you need some process to normalize the data into the vector, maybe containing words representing this document. And the output of this, you're trying to predict whether it is text about technology, sport, or fashion. And there is another type of example. We have a text, and we are trying to examine whether this text is talking about positive information or negative information. So this is also referring to sentimental analysis. So we can know whether the customer giving us the feedbacks positive or negative, and how many percentage of them are giving a positive number. And we would like to remark that text classification is also a part of machine learning. So in machine learning, you can focus on image, which trying to classify objects in the image to be recognized as some particular options. For example, it can be a car, an animal, a building, or some other information. Next, we will see on the types of classifications. We will take a look on the three main different. We have binary classification, multi-class classification, and multi-label classification. So what are the difference between each of them? In binary classification, the classification task with only two possible outputs. So you have only two targets at most. For example, when you're trying to detect whether an email is a spam or not spam, it is considered to be a binary classification because we have only two possible outputs, whether it's spam or it's not. Now we have gender classification, whether something is male or female, or we have movie review if you want to check whether it is negative or positive. However, in the multi-class classification, it's involved with classification more than two classes. In multi-class classification, example is assigned to one and only one target label. Even we can have more than two classes, but our goal is to assign only one label. For example, we trying to categorize, to classify a picture. We want to see whether this one is a cat, a dog, a horse, or a fish. So at a time, you can only classify one information from the text here. And last but not least, we have multi-class classification. Classification task where example is mapped to a set of target labels. It can have more than one class. So you can have many possible outputs, and it can be mapped to more than one class for you. Example, as you can see in this picture, we have many information, right? So these can be classified. We can detect the information in this picture. We have this is a cat and this is a bird. So we can detect many information. And the remark in this one, we have these three types of classification. And in terms of technical term, we can also, it has its classifier. We call it binary classifier, multi-class classifier, and multi-label classifier for each of the classification type that we have discussed about. And next, we will talk about the two main approaches used in classification method. There are two main approaches. The first one is called rule-based, and the second one is machine learning. So in a rule-based approach, you need to provide some set of rules in order that your code can be executed based on your defined rules. And in machine learning, you need the huge amount of training data. So you give a training data to your model and then to your machine learning algorithm, and then you get a model. After you get a model, you can use this model to predict some things based on your input data here. So in hand-coded rules, you need to have the combination of words or pictures given from the text. For example, in text classification, you need some feature to extract from them. For example, in the application of spam detection, you may need some blacklist address. So whatever the address appear in your list, this can be considered as a rule. So in this approach, the accuracy can be high if the rules are already carefully refined by the experts. However, if we use experts to help us in defining the rules, the cost is expensive because it requires many extensive knowledge from experts. As we know that whenever we hire someone, we need to pay a lot amount of budget as well. And next we will see the different type of classifier and what we can do in the tool called scikit-learn. So we have logistic regression, a bias, stochastic gradient descent, decision tree, and all the way to the convolutional neural network, or we call it CNN. So there are many possible classifiers that we can use when we want to perform some machine learning. And text classification is one part in the machine learning. So next we will take a look on scikit-learn. It provides a way to do many possible algorithms ranging from regression problem, classifications, clustering, and dimensionality reduction. So in the scikit-learn, it provides many possible classifiers that we can use. However, we should choose the appropriate algorithm to be used based on our requirements. So from these pictures, I will briefly describe on this. In case that we have the input data is not more than 50, we need to retrieve more data because it's not enough in the machine learning problem. It requires a huge amount of data. So if it is more than 50, we need to check whether we want to predict a category or we do something else. So for living this, we want to do a category prediction, and we need to answer some questions. Do I have label data? So label data here, it means we know the correct label for the input problems. And next we will check whether our input problem is less than some set of amounts, and we do this way in order that we can choose a suitable classifier to be used in our problem. So next we will take a look on some specific more information on algorithm selection. A classifier can be selected based on amount of data sets. We also have discussed in the earlier slide. Normally, data sets are generally divided into training and test sets. So we will talk this further in a following slide on how we can prepare data sets for our machine learning problem. So how we can select the algorithms, it follows similar process as we discussed earlier. So we need to answer some appropriate questions. Do you have label data? If we have, okay, it need to come to the left side here, whether we use a support vector classifier in the support vector machines algorithm. And if it is not working, we need to do something else, whether we can use our test data to perform the testing operation in the evaluation phase. And if it works, okay, we will use the naive bias, or it is not working, we will use some other classifier. But in case that our sample data is greater than 100,000, we can use some other classifier. So next we will take a look on the process in building a classification model. There are four main important parts. The first one is called classifier initializations, in which we need to choose and initialize a specific classifier among many of them to be used. As we seen from the previous slide, we mainly focus on the amount of training data. And next, we have the classifier training that we use to train our classifier using the training data. So from here, if we use scikit-learn, we can use the function called fit, which requires two parameters. The first one is the training data, the input, and the second one is the correct class label. So this one normally can be performed using the supervised classification. And in the third process is called target prediction. We are trying to predict some new data, whether our model is given us the correct results based on our training. And after this prediction, we also have the classifier evaluations, which allow us to evaluate our classifier, whether it is good enough or how trustworthy it is that we can use to solve our problems. So this one enables us to evaluate and find the performance of the trained classifier model. It can be based on various metrics. For example, we have the accuracy, precision, recall, confusion matrix, and some other techniques, and we will discuss in the next following chapter. And if we agree and we pass the evaluation, finally we will retrieve the classifier models, which can be useful to predict a new input data. And here is an example code that we can use to build a classification model using scikit-learn. So the first step is we try to initialize a model. So in this case, we choose the linear support vector classifier and multinomial in the net bias algorithm. And next we do the classifier training using the training data and the correct training label. After this, we need to predict some information, some input data in the training set. And next, after we do the target prediction, we have to evaluate our classifier with the GEEK. It can give us the higher results. So in this case, we use accuracy and confusion matrix. In scikit-learn, it's really easy that we can import and use this function called accuracy score, and you just need to provide the appropriate parameters. And it works the same way for the confusion matrix and precision and recall as well. And here is the four main components in text classification. The first one is feature generations, in which we need to collect data, or we can generate a new data based on the experiments. And then we need to extract some features that are important, that are relevant to our purpose. And next, we need to do the feature selections, which we select only some features. Suppose that we have 1,000 records, but we may not use all of them at the same time. We need to separate them into the different scenarios. For example, half of them or 30%, and the remaining 70%, and you can use in the next scenario, for example. And we have the classification model training, which allow us to train our model using the training data. And next, we have the model parameter training. For tuning, after we train our model, we can adjust the parameters to avoid some of the overfit and underfit problems. And next, it can go cycle in this case. In case that we don't get the appropriate information, the accuracy is not high, we may need to collect new features and repeat the same step again. So next we will talk what we can do with text classification. In this text classification, we can do on the movie review, whether a movie is positive or negative, that we got feedback from our user. So these can be based on the key term which are used in the comment on the feedbacks. For example, as you can see in the first bullet point here, unbelievable, disappointing. So we see the term disappointing here, which is giving a negative impact, right? And the second point, full of Zany character and richly applied strategy and some great palette twists. As we can see, we have the word grades. So normally grade is in a group of the positive information. So normally in text classification, we can, one way is we can separate the information by looking on the key terms that are used. For example, they are in negative, they are in positive. But if we want to try to check more, for example, it is more relevant, more important, or more better, we may need to do some calculation so that we can compare and rank them amongst those criteria. And we can predict the subject of a given article. If we have thousands of articles and we want to know whether each article is talking about different topics, we can also use text classification. It can be about management, admissions, nurse, technology, medical, politics, and many information. And from this analytics information, we can use it for further improvement of our product or company as well. And here are some more tasks involved in text classification. We have spam detection, whether we can detect or filter those spam emails using some appropriate rules or machine learning algorithm. We have language identification, gender or age identification, whether a group of person they are in a particular age or not. And authorship identification, whether a piece of text, a publication, or a book, it is belong to some author, some people that is regarding to the copyright process. And we have the categorized classification, whether we need to assign some topics to a given text. And there are some more than that we can use in text classification also. So next part, we will talk what are the difference between supervised and unsupervised classification. As we have seen from what we have learned so far, we have seen that there are many types of classifiers that we can use, but each of them they are used in different way also. So we should understand what are the difference between supervised and unsupervised classification. In supervised classification, we know what is the class label. That means the output we know for example, we have training data and we have the corresponding correct label. So this input, what is the correct information? Example, this article is about technology. So we know those information in advance, and we also number of classes, number of possible outputs. However, in the unsupervised classification, these information are unknown. We don't know them. And we also need the training sets or in the supervised classifications, where in unsupervised classification, we don't need prior knowledge. And in addition to this, supervised classification, they are used to classify future observations that after we have the model built, we can use them for predict a future input. However, in the unsupervised classification, they are used to understand or explore more data that allow us to analyze what information can be inferred from the current existing data. And in supervised classification, only the predefined class can be found. But in the unsupervised, there might be possible the newer category, newer class or label can be revealed that given new data is used in the experiment. So in addition to this, we also have another one called semi-supervised. It uses the unsupervised methods to improve the supervised algorithms. So it's just a combination of supervised and unsupervised. And important note in here, it uses few label examples. It means that we know the labels in advance, but there are not many of them. And we have lots of unlabeled data. So here is the machine learning algorithms, which is categorized based on the supervised and unsupervised classification, as well as the purpose in whether we try to classify a problem into a category or is into the continuous data. For example, in the plotting graph. So in here, mainly we will focus on this classification type. We have many different types of classifier that we can use. So there is an important note on supervised classification. When we say that a classifier is called supervised, when it is built based on our training data, which contains the correct label for each input. So our input data, we know what is the correct label already. And the method and the process used in the supervised classification, in the training, we have this one in advance already, right? And from these inputs, we can extract some relevant features based on our methods. And from this, we have the feature which are used to fit in the machine learning algorithm to fit our model. Also, the label here need to be passed into the fit functions, as we saw in the previous slide on how we can use the scikit-learn to train a model. So from this, we have a classifier. So whenever we try to predict new inputs, we can do the same process here to have the feature, and then we pass this feature into model. So as a result, it gives you a label which should be mapped into this input. And here is an overview of the supervised machine learning. We have the input and the output. The input should be we have a training set, and which we know what is the corresponding label, or we call it documents. D1, document 1, it has the corresponding class label, and we have many documents, and we have the set of class, which is the set of labels that are correctly used for each document, and we have an input document new here so that we can try to predict it more. And the output of this is that we have a classifier that can be used to predict a new documents, which are in the set. The labels that are predicted from this classifier must be in this given sets, because from supervised machine learning, we know the number of class in advance, and it cannot be predicted outside this set. Next, we will talk on the dataset preparation before we can perform the building a model in either text classification or machine learning. So what is datasets? Datasets are used in machine learning algorithm to train, test, and evaluate our models. And it can also call corpora. So either we use dataset or corpora, it is the same. So normally datasets, we need to divide into two main parts. The first one we call development set, and the second part is we have test set. But in development sets, we can also further divide it into sub sets. We are called training set and delta sets. So these are used in the training. We fit our model, and then we try to test some data, whether our model gives accurate result. And from this, we need to evaluate our classifier using this test set. And next, we will talk on how we evaluate our results once our classifier is built and a new data can be used to predict the result. So why result evaluation is important? In order to decide whether a classification model is accurately capturing a pattern, we must evaluate that model. The result from evaluation is important for allowing us to decide how trustworthy the model is. so that we can use to identify some more problem in the future aspects and what purpose that we can use it for. Evaluation can also be an effective tool for helping us in making a future improvements to our model. Once we found out that there are some faults, some errors, unexpected errors happening from our experiments, we can try to improve them in the future experiment as well. So this can be obtained, that can be collected from the evaluation part. And evaluation result we can consider on, there are some more of them, but these four main points are important, which are used in the normally appear in the machine learning. We have accuracy, precision and recall on F1 score, and we have confusion matrix and classification report. Actually, this one is the main important, which will be used in some other metrics. So what is accuracy? It is a ratio of correctly predicted observation to the total observations. So normally people tend to use accuracy. It is the way that we try to evaluate the results. For example, we have 100 articles and we want to classify them into a category, whether they are belong to some topics or not. So suppose that among here it has we can predict 80 of article are correct, identify as the correct label, and we have the 20 is not correct. So from this, the result of the accuracy can be 80 over 100, because we can predict correctly 80 out of 100. So when we talk about the accuracy, we will see some term is called true positive and true negative. So what is true positive? It is a number of correct predictions that occurrence is positive. We predict it is positive, and based on the correct label, yes, it is positive, so it is true. So we say true positive. And in true negative, that means you predict something in a negative, and then the correct label is also negative, so it becomes true, or we say it true negative. And next we'll talk on S1 score. S1 score is an average of precision and recall, and F1 score is usually more useful than accuracy, especially if you have an uneven class distribution. So accuracy, normally we have problem when we have the unbalanced data. We have for example, we have two type of class, 1 and 0, and those data for each class are not balanced. So they will cause a problem in accuracy evaluation. So what is precision and recall? Precision, when a positive value is predicted, and we want to know how often is the prediction is correct. But in recall, when the actual value is positive, and we want to know how often the prediction is correct. So there are the formula used in accuracy, precision, recall, and S1 scores. For accuracy, we need to find the total prediction, total correct prediction over total samples. And precision recall, we need to relate this to what is true positive, true negative, false positive, and false negative. So we will take a look on what is the true positive, true negative are. Suppose that we have the actual class, we know this in advance from our training set, and from our predictions, we have the whether we can predict it correct or not correct. So when the prediction is positive and the actual class is also positive, this will lead to the true is correct, and we say true positive. So this is the correct result. And when we predict it is positive, but the actual class is not positive, so that means it gives the different answer, right? So it is false. So we call it false positive. So remember that when you have T P here, for example. So normally this one is what our model predict. And this one, we check whether our prediction is correct or not correct. If it is correct, it will give true. If it is not correct, it will give false. So normally we have TP, we have TN, true negative, we have false positive, and we have false negative. And for the formula, it is already defined for precision and recall, which is true positive divided by summation of true positive plus false positive. And the difference between precision and recall, we just focus on difference whether it is true positive or true negative. And in F1 score, it is an average between precision and recall, and the formula is 2 times precision multiply recall divided by precision plus recall. So each of these evaluation criteria can be used from the scikit-learn metrics package, which can be used via this function. And next we will take a look more detail on the confusion matrix. What is confusion matrix? Actually, it is also known as an error matrix. It is a table used to describe the performance of a classification model, or we call it classifier, on a set of test data for which the true values are known, in case that we are using in the supervised learning. So we have our prediction and we have the actual label, and we need to check whether our prediction and the actual answer is correct, which is regarding into the true negative, true positive, false negative, and false positive. And next we have the classification report. It shows us a representation of the main classification metrics on a per class basis. And it gives a deeper intuition of the classifier behavior over global accuracy, which can mask functional weakness in one class of a multi-class problem. So in my classification report, it gives you many informations. We have precision recall F1 score, and we have another type of evaluation criteria. We call it support. And we also have the accuracy and some other weighting methods. So normally classification report gives us a general representations of the result so that we can use to evaluate whether our model is correct or it is a fiction. And here in this slide, it gives you a code part example using scikit-learn. It's not a complete code that you can use to run a classification problem, but it gives you an overview process on how you can use scikit-learn so that you can predict, you can perform some method in either text classification or machine learning algorithm. You have the model classifier initialization, and you train your model. So make sure that you have your training data and as well as the train label, because this one is in the supervised classification in which the correct label are known. So after we train a model from here, we can do the predictions. So from the prediction, we have the result. And next, we can use this package to show the evaluations results from our resulting prediction. So we have confusion matrix, average score, precision score, recall score, F1 score, and last but not least, we have classification report, which gives us more important information to evaluate our model. So from this result, we can decide whether we should collect more training data to train our model, or we can say that our model now it is a fiction that we can use for further problem. So now we have some homeworks for you. I hope you enjoy the lecture and understand some more concepts from this lecture. It is quite introduction part, but it is cover most of the important aspects in both text classification and machine learning. And in addition to this, and there are some more methods as well as the concepts that I also use in the text classification. So please try to answer these questions. The first one, it is about term document matrix. Sometimes we also call it term document matrix. Give some example for this one and some other more information which allow you to understand more in the text classification. So thank you for enjoying the lecture today, and we hope to see you in the next lecture. Thank you.